I'll just speak few words about Shri Arvind Srivatava ji. He is an outstanding scientist and he was heading the civil group in NPCIL. And he is considered expert in seismic and wind analysis. And he has been several countries deputed there for various technical discussion and presentation. So I request now our Arvind Srivatava ji to start.
Good afternoon and thank you very much, Anadi Kumar Sinha ji. I am really thankful for the Indian Nuclear Society for giving me this opportunity to talk about the siting of nuclear facilities. I would like to just share the basic information available in the regulatory boards, atomic energy regulatory boards. They were designed, they have developed AERB codes and various guidelines to decide the siting of nuclear facilities in India. Next, please. So when we talk about the stages of site selection, broadly we are having two stages. First we call site selection or the identification of a particular site. Once we decide, we identified this is the site which is going to be there for construction of NPP or nuclear facility, then comes the stage 2, that is the site survey and site evaluation. Next, please. Now there is a small diagram which I have collected that basically depicts the site selection and approval of NPP facilities. This is basically, in general, the Government of India and the DAE, basically it constitutes a site selection committee. This I am talking about the NPP, whatever are existing in the control of Nuclear Power Corporation, because I spend most of the time there only. So this just gives a glimpse of what are the various activities which are really going to be there for the approval stage for a site selection. After the site selection is constituted, then we carry out the site investigation. For that actually we get the proposals from various states in India. That work, whatever is done by the earlier site selection committee, is also taken into consideration. Siting criteria which is available in the regulatory guides, standards, they are reviewed, they are followed, and based on that the technical committee or expert groups are formed, and on that basis the site investigation is selected. Once this is completed, then a report is generated. That reports get the feedback from the CEA, Central Electricity Authority's inputs. And that report, what we call a site selection committee report, that based upon the government policy, and that on that report we get the in principle approval by the government. Now when this comes, then the real starts work for the site approval process. Now you know that approval means we have to interact very closely with the regulators. Mainly we have two regulators, Atomic Energy Regulatory Board, which are responsible for the consents, for the safety considerations. And of course the State Pollution Control Board and Ministry of Environment and Forest. We also seek the clearances from these departments. Once the various stipulations made by the codal provisions or the information to be taken or to be collected or to be analyzed as per the guides are available, we made the formal submission, and that is how the review takes place at the regulatory levels and we get the site approval process. On that basis, we can say the project has been approved by the Government of India. So this is in nutshell the total network which is basically involved at the various departments at various steps. Now, site selection stage, the guidelines to be followed for empaling a site have been defined in enclosed tables which is going to be there. It is based upon mainly one code, that is the governing code. What we say AERB safety code number AERB NFSCS, that is the site evaluation of nuclear facilities. Based upon this basic code, AERB has also developed AERB safety guides, AERB SG S1, 2, S2, S3 and S11. So these are the basic documents which are required to be followed for the site evaluation. Now these are the various safety guides which I mentioned in the previous slides. For SGS1, atmospheric dispersion is covered. S2 talks about the hydrogeological dispersion. S3 talks about the extreme values of meteorological parameters. 4 talks about the hydrogeological aspects of siting. S5 talks about the model of radioactive dose computation methodologies. 6A and 6B, that is for design basis flood for inland sites as well as coastal sites. S7 talks about man-induced events. S8 talks about influence of site parameters on emergency preparedness. S9, population distribution. S10 about the quality assurance in siting. Last but not the least, S11, the seismic studies and design basis ground motion for nuclear power plant sites. These guides really help us to evaluate the various parameters which are required to qualify a particular site to facilitate the nuclear facility. Now the brief outlines of screening criteria are also summarized, which is taken directly from the AERB code. Next please. So these are the screening criteria. What they say, when you talk about the seismicity, what they say, the essential requirement, desirable requirements and remarks, I'll come to these two columns at a later stage. Right now, let us talk about what code says. So as regards the seismicity, it says site falling in seismic zone 2 to 4 are only acceptable. Now here I would like to mention that seismic code basically we are having right from 1962 onwards, wherein actually it was a very primitive stage. At that point of time, usually we were talking about the importance of a building. And at that time, actually, there was not detailed seismic evaluation methods were available. We were getting for the equivalent static approach, wherein equivalent static approach means some seismic coefficient has to be taken care considering the various zones. On that basis, you have to apply some factors, on zone factors, and on that we have to apply one importance factor, what we call I. So I'm talking about a very old one. That importance factor for NPP was 6. For other important structures, it was again 5, 4, 3, 2, and 1. Now, recently, the code has also gone several changes, and now the code stipulates the zone itself. Now, zone 4 to 5 and 6. So now there are 5 zones. Zone 2, zone 3, zone 4, zone 5, and zone 6. What code says that now the stipulation remains same, that particularly in the Himalayan region where the zone 5 and zone 6 has been categorized, the nuclear power plant on account of seismicity cannot be located. Although this approach is being dealt separately, but for the present discussion, let us just assume that it is always better to have our siting site is falling in the zone 2, 3, or 4. So let us not go to zone 5 or zone 6. Next comes to the distance from the capable fault. See what happens when you carry out the seismic studies At a particular site, you have to basically take the data from 300 kilometer radius, and you have to mark various faults, fractures, lineaments, and whatever geological features are available. And on that basis, actually, you have to evaluate whether we have any capable fault which can really responsible to give the vibratory ground motion which can severely affect the site. So, as a screening distance value, they say this capable fault should be more than 5 kilometers from the reactor center. Third comes from the airfield. This again, screening distance value says more than 5 kilometers should be good enough to rule out the possibility of any effect. Then major field, it says about more than 8 kilometer. Military airfield is more than 15 kilometer. Next please. Distance from storing, involving, handling inflammable, toxic, corrosive or explosive materials and mining activities from site should be again, it's not essential, but it say that desirable. So here it comes the desirable concept. It's not essential like capable fault or military installation. It says desirable, it should be more than 5 kilometers. Okay. Next is distance, military installation, storing ammunition, etc. Now here is the compulsory. It should be more than 10 kilometers. Next please. Next comes the criteria as the design criteria, what we call about the grade level above the astronomical tide. Now this is applicable for the coastal size. What they say that essential requirement is 4 meter and desirable it should be more, 6.5, because there are uncertainties associated with the coastal sea. So on that basis these values have been determined and they have been put in the code. Popul density desirable criteria, it says less than 2/3 of the state average. Population within 5 kilometer radius is less than 20,000. These figures I have directly taken from the codal. Population center more than 1,000 should be located more than 10 kilometers. Population center 1 lakh, so more than 30 kilometers. Next. Place of architecture, historic, monument, essential requirement because population is involved, so more than 5 kilometers. Then comes the flooding. What they say for flooding, basically, it's a phenomena which is directly relating with the site grade level. So what they say, the site grade level should be at least equal to the safe grade level. Now how to decide the safe grade level? Site grade level, in nutshell, with some margin. That margin could be X, Y, Z. That can be decided. So in remark, if you see the safe grade elevation to be evaluated for flooding due to combination of highest high tide plus storm surge or tsunami surge, whichever is more, plus wave run-up. So this is applicable for the coastal sites. Okay? So with some margin. Freshwater requirement, construction stage, you should have 100 cubic meter per hour. Coastal region, if you want to say, for example, you are having 4 units at a site, then planned township, what they say, 15,000 cubic meter per day, for township 1,000 cubic meter per day, total around 16,000 cubic meter per day. If it is inland, then you would like to have the natural draft cooling towers, and their requirement is 24,000 cubic meter per hour. So the quantity can be spared from the existing source, may be indicated. That's what it is giving. Next. If you are having a once-through system, then seawater for cooling water, 1,000 megawatt unit should have 3 lakhs cubic meter per hour. Power requirement has been given, construction power and startup power, minimum 10 MVA and minimum 80 MVA respectively, from 2 different independent sources. Land requires for a plant site around 1,000 hectares for 6 units, 840 hectares for 4 units, township approximately 300 hectares. Next please. Power evacuation, feasibility for smooth power evacuation for about 600 megawatt, that is for 6 units. And when you talk about the nuclear power plant construction, definitely there will be a massive equipments which are going to be transported from the respective workshops or factories to the site. So, over-dimension consignment movements should be keep in mind, and wide roads and nearby port facility is better so that you can transport in a easily way. I think I already explained the capable fault is one which significant potential for relative displacement at the near the ground surface. So these are the only brief initial screening criteria. Acceptability of a site will be based on detailed evaluation. This is only just screen distance. Okay, this figure like this. If this is here, don't do. If this is here, don't do. This is a very nutshell. Okay, next please. So now let us talk what is site. Sorry, I am starting from a very primitive level. I know that here so many experts are available, so please excuse me if I am crossing my limits. So as per the, again I am referring my AERB code only, as per code stipulates the, what is site? The nuclear power plant, the site is defined as an area surrounding the plant defined by a boundary and under effective control of plant management. Very important, effective control of plant management. And what is siting? Siting is the process of selecting suitable site for a facility, including appropriate assessment and derivation of the related design basis. That's what we have highlighted. So the siting process involves two basic stages: site survey and site evaluation. Site survey means what? So here are the basic activities during site survey stage. That is the identification of a prospective location. Once you decide the location, then collection of the information or data related to factors affecting the site selection. Third one, conducting preliminary investigation. It's a very loaded statement if you say collection of information and data related to factors affecting site selection. The information to really evaluate a site is very massive. I will try to highlight some of the data which are required to really evaluate the site in next few slides. Site evaluation means it involves demonstration of acceptability of the site on the basis of established criteria for selection of NPP sites, and then the derivation of site related design basis. Now one more important thing we should always remember, that siting, it's not that you evaluated site and it's the end of the game. No. Site evaluation is a continued till the end of operating life of the plant to ensure safety against hazards associated with the events of origin external to the plant operation, called the external events. So they are keep on changing always. It's not that today it is there, tomorrow it won't. No, they are changing. So you have to keep on evaluating the site. This is important due to the changing perception of the hazard from the external events, as well as changing natural or human-made environment in the site region over a period of time. So that is why it's a continuing evaluation process. Now here are the different stages during the lifetime of the nuclear facility. The first and foremost comes the siting. Once you get the approval from the siting consent, then actually we design, we analyze, we design the nuclear power plant structures. Once they are designed and we go to regulator, they review our design at various levels. Then they give the consent. On the basis of the consent, we start the construction. That starts from the excavation, then first floor of concrete, equipment erection, so on and so forth. Once the process completes the construction, then comes the commissioning, operation and decommissioning. Next. So what are the objectives? I have highlighted some of the objective of the siting of NPP. So the main objective in siting nuclear power plants from the point of nuclear safety is, I think it is already talked about by my previous speakers, to be able to construct and operate nuclear power plants safely and to provide protection to the public against radiological impact. This is the main objective. I think it is already talked about our previous speakers also. So the basic criteria for selection of a site for the location of a nuclear power plant site is to ensure that site-plant interaction will not introduce any radiological risk or others of an unacceptable magnitude. Next. How we achieve this? This we achieved by ensuring the radiological risk to the nuclear power plant due to external events should not exceed the range of radiological risk associated with the accidents of internal origin. I think Mr. Hajela also has highlighted. And second, the possible radiological impact of a nuclear power plant on the environment should be acceptably low for normal operation and accident conditions and within the stipulated criteria for radiological safety. That's how we can achieve. Moment we control these two parameters, we are ensuring. So, safety aspect and factors governing the site selections. Safety of the plant, personnel, public and the environment from radiological hazard is one of the most important consideration for siting of the nuclear facility. Like any other facility, nuclear power plants are designed to withstand the forces due to hazard from external events caused by natural phenomena like earthquake, wind, tornado, cyclone, so on and so forth, flood. The magnitude of such force in case of NPP is derived based on a very detailed and stringent criteria compared to the other conventional facilities, and these are termed in our terminology as the design basis. So, previous madam. So basically, I want to highlight that there is a difference between the conventional structures and a nuclear facility structures, systems and component. Stringent requirements are forced right from day one, and that should be always kept in mind. Next. Now, which are the various aspects which really govern the site selection? So, in evaluating the suitability of a site for locating a nuclear power plant, the following major aspects are considered. First and foremost, effect of external events, that is natural and man-induced on the plant, how they are influencing. Then, reverse of this, effect of plant on environment and population. First is reverse of second, okay? Third is implementation of emergency procedures, particularly protective countermeasures in public domain, and the effect of other facilities on site. Now let us elaborate these. Please, next one. So factors affecting site selection of NPP. The important factors affecting selection of site for major industrial installation, including NPPs, are infrastructure, economics, sociological aspects, general safety in terms of impact on public and environment, and technical feasibility, and last one, the engineerability. I'll come back to this in later slides. Next. So criteria for site selection, we are going to discuss now these slides. So criteria for NPP siting is site-specific criteria should be applied. There should be general design criteria, design basis for external natural events, design basis for external man-induced events, radiological impact on the environment, population consideration and emergency measures. Next. Now site-specific. Can I have some water, madam? Sorry. Now, site-specific criteria that may affect the safety of NPP are investigated and assessed. First, you have to investigate, then you have to assess. Then, frequency and severity of external events and phenomena, natural and man-made, both are to be examined carefully. Events having a very low probability of occurrence are not required to be considered. That is the concession given. A probability value of 10 to the power minus 7 per year is considered low for this purpose. Next. So proposed sites for nuclear power plants are examined with respect to the frequency and severity of the external events and phenomena, natural and man-made induced that could affect the safety of the plant. So design basis external events are determined for the combination of proposed sites and nuclear power plants. All those events with which significant radiological risks may be associated are selected for consideration and their design basis determined. For external events, design basis parameters should be such as to ensure the structure, system and components important to safety will remain their integrity and will not suffer loss of function during or after the design basis event. This is the most important criteria. If, after thorough evaluation, no engineering solutions can be found to provide adequate protection against design basis external events, site shall be deemed unsuitable for the location of the NPP of the type and the site proposed. Next. So for such general design criteria, now let us talk about. For such proposed sites, the potential radiological impact on people in the region during operational states and accident states shall be compulsorily assessed. In assessing the suitability of the site, consideration shall be given to safety aspect of storage and transportation of new and spent fuel and radioactive waste, possible radiological consequences in the event of locating a reprocessing plant for the spent fuel with associated waste treatment facility should also be considered. I think my previous speakers also highlighted some of these aspects. So, in nutshell, the site is re-evaluated in the following cases. Now this term is re-evaluated, just mind. If the total nuclear power is increased to a value greater than what was previously specified in that case, and if there are any expansion activities around the site in the future that may have a radiological impact on the site. So, on these two guidelines, it should be re-evaluated. And suitability of the implementing emergency measures effectively in case of an accidents are determined. Next. Now talk about the design basis for the external natural events. Natural phenomena are identified and are classified as per their importance. Historical records of the occurrence and severity of the important natural phenomena are collected for the reason data are carefully analyzed for reliability, accuracy and completeness. If data for a particular type of natural phenomena are incomplete for a particular region, the data from other regions which are sufficiently similar to the region of interest may be used in the formulation of the design basis event. This is a regulatory language. I'll try to just give some insight. When you select a particular site, definitely you may not have the data. What to do? In that case, what they say, if you have already thought that, yes, this is my site, try to collect the site-specific data as soon as possible. Not all, whatever is possible. Say, for example, wind data, its frequency distribution, it can be easily collected. You need not depend upon the Indian Meteorological Department, that's the stage, because IMD is having a different places to record their various values. Not necessarily, actually, they will be applicable to your site. Certainly, you can take those data as a preliminary work, and then probably you will have to substantiate whatever the data we have taken from a IMD station, which is say 20 kilometer or 10 kilometer away from site, it still holds good. So via media is, if it is possible, if you have decided, try to get more and more data, collect for your site so that you can try to extrapolate the data based upon the adjoining data available for your analysis. This can be applied to even seismic also. Not detailed one, but very seismic station can be installed once you decide the site is frozen. Next one. Now, proposed site is adequately investigated with respect to all the design basis man-induced events that could affect the plant safety. Now, the site is examined for facilities and human activities that may affect the safety of the NPP. Information concerning the frequency and severity of those important man-induced events are collected and analyzed for reliability, accuracy, and completeness. And for most of the criteria, SDV, considering both probability of occurrence of the concerned event and the impact on plant sites, are evaluated. That's what we discussed in the earlier slides. Next, please. Now, radiological impact on the environment. So, impact on the environment arising out of operating of the NPP should be as low as reasonably achievable, what we say ALARA principle, for normal operation as well as accident conditions. The direct and indirect pathways, which are air and water, by which radioactive materials released from the nuclear power plant could reach and affect people, shall be identified for use in the estimation of the radiological impact. Impact on the environment arising out of operation. So, radiological impact on the critical group as well as to the public as a whole due to operation of nuclear power plants are considered and evaluated. Effective implementation of emergency measures in case of an accident. We consider emergency measures. Population characteristics and distribution in the region studies, and data on permanent resident, transient, seasonal population, present and future use of land and water resources, cattle and livestock, agricultural produce, fish catches on annual basis are collected and reports are generated. Now comes the effect of site characteristics on NPP. So, site characteristics, first let us talk about the natural, seismological, geological consideration. Next is the geotechnical. See, it's a very enveloped word. Geological, geomorphological, geophysical, geotechnical. Now, this is a very huge database, like geotechnical. The most important thing is liquefaction. But liquefaction is applicable only for the alluvium deposits. It may not be relevant for any site which is having a hard rock. So it is immaterial. But yes, wherever there is a alluvium like Narora or GHAVP or any other site which is going to be there on alluvium deposits, liquefaction is the most important phenomena which must be dealt with very careful considerations, and it should be evaluated based on so many soil parameters and earthquake parameters. Otherwise, it can be a difficulty for qualification of a particular site, particularly for the alluvium deposits. Slope instability, site surface collapses, subsidence or uplift either way. Hydrological flooding at site, internal or external origin. Extreme meteorological events like wind, shoreline erosion. Next. Then what about the man-made? Man-made could be aircraft crash, chemical explosion, toxin gas releases, oil slick, blasting operations, mining drilling, water extraction, extreme meteorological events, wind, shoreline erosion. Other characteristics like regional energy source and demand, power evacuation and its stability, manpower, material, roads and railways, transportation for over-dimension consignments, foundation considerations, thermal and chemical pollution, extreme meteorological event again getting repeated, wind, shoreline erosion. And other characteristics are, we must have land available with us. Once land is available, there should be the availability of water. Third one is the construction power. Now the effect of NPP on site. So site character nature is the dispersion through air, dispersion through sea water, dispersion through subsurface water, underground water, population distribution, land and water use, consideration for the emergency planning. So this picture shows that desirable should be water should be available. If there is no water, certainly we cannot select a site for NPP area. So for mandatory criteria, what they say, engineering measures possible for site qualification based upon whatever the data we have gathered for the site evaluation, it should be able to qualify. Suppose we are not able to qualify, then we should go for the top. That is the engineering measures not possible for site qualification. Next. Now let us do slightly more. Sorry, there is a correction. This is not exclusion zone. Actually, it should be 1.5 kilometer for the unlined containment projects and 1 kilometer for the lined containment. And sterilized zone 5 kilometer, land availability I think I have already explained. For 2 units of 1000 megawatt will be around 200 hectares. Land should be barren without much cultivation. This is a requirement, okay? No forest land. Grade level should be above design flood level. So first you have to estimate design flood level. Now how the design flood level comes? Depends where your plant is located. Whether it is located inland, then it will be dam break, precipitation, flooding consideration. If it is on the coast, tsunami, wave runoff, so on and so forth. So these two are different criteria. Then at least 5 kilometers away from the storing influence that I think we have already discussed there, away from international borders, availability of more than 2 evacuation routes. There should not be a single route. You should have 2 independent routes for the evacuation. And in sterilized zone, natural growth of population is permitted and is under administrative control. Next. So here is the pictorial view. We have decided, we have just defined here exclusion zone as 1 kilometer radius. No habitation is possible. Then sterilized zone, that is regulated growth is permitted here. Emergency planning zone, that is action plans drawn for the public, that is 16 kilometer radius. Next. One more pictorial view wherein we have added one more parameter, that is the plant boundary, that is 500 meters. So this is just one more pictorial view. Next comes after land, next comes the water. Because the land and water, these are 2 very important parameters. So water for condenser cooling and other use, what they say for 2 units, once through is 4 lakh cubic meter per hour. If you have the cooling water system, that is a closed loop, that is the cooling towers provision. In that case, the 24,000 cubic meter per hour for the makeup, a consumptive will be 12,000 cubic meter per hour. If you have a coastal site, seawater, then once through cooling, 4 lakh. But check is, it should not have much turbidity and carbonates. Then you should have a fresh water for the plant, 1000 cubic meter per hour. Fresh water for township, 500 meter cube per hour. Next, madam. Now third is the environment. Avoid forest land and sanctuaries, bird sanctuaries. Water pollution as guidelines of Pollution Control Board. Thermal pollution as per mandatory guidelines of Ministry of Environment, Forest, and radioactive effluent discharge within IRCP, International Commission for Radiation Production Limits. Electrical system, nearby availability of startup power, proximity of load centers for economics of the power transmission. There should be sufficient load which is available. So it will be easier for us for the economic consideration. Appropriate power demand for the life of the plant. Then let's talk about the meteorology. From meteorology consideration, atmospheric dispersion should be good. Atmospheric inversion should not be there. It should not happen, it is getting inversion. Avoid areas prone to cyclone, hurricanes. Preferable to have not much variation in temperature. Preferable to have as population and population centers in predominant wind direction, so that when wind blows, the effect on the population should be the least possible. Next. So the population of the district shall be 2/3 of the state average population. As little as possible, population in the exclusion zone. No population centers with population more than 10,000 in 5 kilometer radius. No population centers with population 1 lakh in 30 kilometers radius. Total population in the sterilized zone should be less than 20,000. For land use, not much cultivation in the land within 10 kilometers. No reserved forest. For water use, avoid areas with large fishing activity. Avoid areas with groundwater substantially. Avoid areas having shallow water table. Next. Now come to the subsoil condition. Preferable to have rock foundation. Why? So that deformations are within acceptable limits. Avoid areas prone to liquefaction, surface collapse, subsidence or uplift. Once you are having liquefaction means it will be soil site. So if you are not having soil site, this problem is not there. Seismic. Already explained, site should be in zone 4 or below. So 2, 3 and 4. 5, 6, not possible. Detailed seismotectonic and seismological studies in 300 kilometer radius area has to be carried out, as explained earlier. And we have to carry out detailed study to determine the site-specific operating basis earthquake and safe shutdown earthquake. For flood analysis, say for coastal site, astronomical high tide level, wave surge up, wave run up and tsunami to be considered. For inland site, maximum water level due to precipitation and dam break to be considered. Provision to avoid flooding at site. For that, site safe grade level based on the flood analysis to be decided. At all costs, site should be away from flood. That is a nutshell. Next. Solid waste management, area preferred with rocky strata, deep groundwater table, and minimum irrigation around site. Radiological burden on the atmosphere due to the associated facilities to be within IRCP limits. And site should be accessible by roads and railways, transportation by ODC, over dimension consignment, 2 independent emergency evacuation routes. Next please. Now here are a few acceptance or rejection criteria which we have discussed so far. As I told you, in siting requirement, seismicity is very important. But here they say rejection standard, site falling beyond 4 should be rejected. What? Site rejected is fine, but what about they are falling in zone up to 4? So those are to be evaluated in great detail. Distance less than 5 kilometer. Suppose it is not there, then what? So they say detailed evaluation should be carried out for identifying the fault. So some breathing. Then of course airfields, major airports I already discussed. Next please. This also we have discussed. Only thing is that previous. Under remark you said detailed analysis shall be carried out regarding the impact of toxic and hazardous gas release under the postulated condition, and site shall be deemed as rejected if safety is not established. If you are able to demonstrate the safety, okay. If not, no. This also I think we have discussed. Distance from military installation 10 kilometer. Groundwater depth should be more than 2 meters from grade level. Grade elevation above astronomical tide is 4 meter and 3 meter from the eastern coast and western coast, depending upon the data available from east and west coast regions. What they say, detailed evaluation at site stage shall be carried out to arrive at the sill water level. Terrain reasonably flat up to 20 kilometer. Valleys with hills on either side at distance 20 times the ridge heights are acceptable. Bowl-like structures need analysis at design stage on a case-by-case basis. This from the dispersion consideration. Population density, I think we have already discussed this. So, in complex terrain, expert judgment shall be made based on the topography and meteorology. Site shall be considered as acceptable if implementation of emergency measures under excellent condition can be ensured for the entire population. Off-site emergency response plan prepared by the applicant should demonstrate adequate capability to handle such situations. So this is the via media given. Next please. This I think we have discussed. So now talk about some of the rejection criteria. So let us not cite any site which is falling in the zone 5 and 6, or site which is having a potential for liquefaction, fault which is capable fault or active fault, which is less than 5 kilometers, or site prone to the ground movement, subsidence, slope instability, or formation of sand dunes. What they say, frequency they talked about 20,000 per year, less than 5 kilometer, major 8 kilometer, military airfield 10 kilometer, military ammunition 10 kilometer, mining 5 kilometer, grade elevation less than 4 meter and 3 meter respectively from the east coast and west coast. Next. So now what are the challenges? In my view, the most challenging is the land acquisition, which is also a part of rehabilitation and resettlement. Second is physical accessibility of new sites for conducting site-specific investigations. Third, collection of adequate relevant meteorological data at new sites for carrying out extreme value analysis. Limited number of expert agencies available for conducting specialized investigation for multiple sites in a short span of time. These challenges I have narrated based upon my experience. I don't know how relevant they will be now, but I feel that this can pose a new challenge when we talk about the huge expansion of nuclear power, say around 2047, 100 gigawatt or so. Of course, these are the various agencies, various acts from where actually we have taken the information, supported by the ARV codes and guides. Next. So thank you very much for your kind attention.
Thank you, Srivatava ji. Thank you. I will take some questions. Kindly tell your name, your company's name.
Sir, thank you for the nice lecture. Sir, could you please elaborate the effect of change? Sir, I am Saikat Pal from Engineers India Limited. Sir, could you please elaborate the effect of change in seismic zonation map on the siting of nuclear power plant? Because some sites which were earlier in maybe in moderate risk may have changed into high risk. So what if we have started investigation in such a zone which was earlier falling in moderate risk zone and now it has been transformed to high risk zone?
Very nice question. I don't know whether I should reply. You may not quote me, so let it be here in this room only. Sir, with your permission. As far as Nuclear Power Corporation is concerned, I can say that we have tried to take the waiver to follow this IS code application, particularly from the seismic consideration. It doesn't mean that we will put our plant in zone 5 and zone 6. As far as zone 5 and zone 6 are concerned, absolutely no chance. What I'm trying to tell you, when you talk about the seismic, because you talked about the seismic forces, as I told in the beginning, seismic code is right from day one, from its inception. It is using the importance factor, then revising response spectrum method, time history method, equivalent static approach, pushover, and so on and so forth. What they were telling, in fact, I was a member of the code committee in IS. So what they were telling, you generate your site-specific data. You generate your operating basis earthquake. You generate your safe shutdown earthquake considering 100 years, 10,000 years, whatever it is. But you have to superimpose my IS spectra on your design basis ground motion. Which we felt, sir, we are doing a so much deterministic, probabilistic approach. On that basis, we are arriving at these data. Why we should follow the IS code spectra, which is having a known conservatism, because general public do not carry out such a huge investigation for their structures. So probably from this consideration, it has been delinked. As far as the use of seismic input ground motions are concerned, I don't know whether they will say that no, you don't design, but you qualify. You understand? The design and qualifying, there are two different approaches. So I think I answered your question, but certainly zone 5, zone 6, to my best of my knowledge, it is not possible. Because it's a highly seismic zone, and they have demarcated, particularly if you have seen the IS code map, all entire Himalayan region, which is basically all Himalayan Shivaliks and that region. Like Uttarakhand is one state I understand, which is really coming in some part of the J&K and Punjab region, which is basically coming under this zone. So in my view, I'm sorry, zone 5, zone 6, it is not possible.
And sir, is there any guideline for the design basis with respect to size of the power plants?
It has nothing to do with the site. As I told you, nuclear facility. Whether you want to, again, there is a classification of the structures. Safety classification, seismic classification, quality classification. When you talk about the safety rated structures, in nuclear fraternity, there are safety-rated structures and non-safety-rated structures. So there are different levels of seismic parameter defined under different load combinations. So you have to design based upon that. Suppose it's a non-safety related. You need not design for the higher spectra for that. That concession is available. Let me definitely admire the AERV. Sir is not here, Shukla sir. Really, he has done extensive work for the formulation of various codes, various guidelines, not only for the siting, but also for the analysis and design. It's a Herculean task. It is not an easy job actually. But they have really given, I'll narrate. Sir, can I take 2 more minutes? I will tell you, in Tarapur containment, raft and containment wall and dome, no? It is basically designed by 3 different codes. Raft is designed as per ASME section 3 division 2. Containment is designed on RCCG, which is a French code. Internal structure, Calendia world, it is designed as per the ACI code. What happens at interface at the raft? We have repeated 3 analysis. At least this problem was appreciated by the regulators. They have formulated the CSE1, CSE2 and CSE3 code by considering various approaches. And now at least we can say single code is applicable for all of us to really analyze and design our nuclear structure, nuclear facility. I hope I answered your question.
Thank you. Thank you very much, sir.
Sivam Anand from ARB only. Sir, do you want to confirm that IS 1893 that published in last year 2025 is not applicable for NPP or?
I didn't say that. I said we have persuaded them that please don't ask us to design our structure based upon the superposition of the IS 1893 spectra.
Okay.
You understand?
Yeah.
Because in some frequency range it is basically governing, you know.
Yeah.
I think you understand that. So we have persuaded and mostly they have agreed. That's what I got the information, sir.
Okay.
Any other questions?
A gentleman is there.
Sir, Sriram from Connectrix. I had a couple of quick questions. In terms of siting, if you look at several international jurisdictions, there is something called consent-based siting, where you have to take the consent or engage with the local indigenous communities. Is that something that is a requirement here is one question. The other question is, what about co-location? So when you look at hybrid energy systems, which is being considered all over the world, you could actually use some of the energy coming out of nuclear power plant to produce hydrogen. They call it pink hydrogen. There are considerations in other jurisdictions where it is suitable to produce hydrogen. And where there are these considerations for hybrid energy systems, where nuclear plays a role in production of hydrogen as well. Are those considerations in the system siting framework or not yet? That's the question.
Yeah, your first question, I think it will not be answered by me. Probably tomorrow our chairman, sir, would like to address it. Okay, sir.
Consent of public is necessary, and that is done by Ministry of Environment and Policy. Because radiation is not the only thing which public is worried about. We are losing land, we are losing some facilities which we were using, therefore we have footpath passing to that. There are many other areas. There are social effects of that. So it is actually conducted at the national level by Ministry of Environment and Policy. When they conduct that, NPCIL or plant authorities are part of it. They will also have to answer their part of the question. We have to satisfy. But that is not the only thing. There are many other things. So it is not conducted by NPCIL or AERB. It is conducted by Ministry of Environment and Policy.
And what about the co-location and hydrogen type of?
So today, he has actually explained that it is desirable to keep certain chemical things away. Desirable. Not mandatory.
Okay,
And
understood.
today we are producing hydrogen in some of our plants
Okay.
for our own use. Right? So it is desirable. If we can demonstrate that industrially we will not be an accident, it will be possible.
Okay.
We are having express plants right in our own.
Correct,
Yes.
correct.
Any other questions? You-
Yeah, Shivashish from Tata Consulting Engineers. So similarly, why not solar PV plants in exclusion zone? Because they can be all, they are allowed, right?
We are having wind already in our.
Yes, yes. Yeah, yeah. We are having 10 megawatt, that kilowatt, yeah. Yes, yes. Already there.
We are having a lot of empty space.
Yeah. Yes, yes.
I want to ask question. With permission of our chair, I am asking the question. See, I remember in 2004 we had tsunami, I think Indian Ocean actually. Then our maps was actually affected to some extent. And I thought it is all external thing only. What I wanted to know is whether it was site clearance had considered the type of tsunami that was faced by maps, and or whether some additional work was done after that tsunami accident. That is one question. Second, I just wanted to know that sometimes the site is cleared, plant is set up and start operating. That somewhere I was seeing that you are also talking about the over the period lot of external concerns are there where the seismic conditions also change, for over the period of maybe few decades. So has there been any case where internationally where they had to rethink or make some changes in the plant once those things came into the notice? Once the plant was cleared at a certain stage, and over the period some other concerns were shown with respect to the seismic condition, I mean siting related things like that.
Sir, let me try to respond to you the second question first actually. Sir, you know that we design nuclear power plant structures based upon the prevailing applicable codes and guides. Whatever is available at that point of time, we design the structures based upon that. Now, whenever there is any increase, in that case, what they say that you have to qualify. There is a difference between the design of a structure and qualification of a structure. Certainly, if somebody certifies that the seismicity has increased based upon these parameters, in that case, definitely we will have to qualify. We cannot design. See, higher level we cannot design. Only then we can see whatever the margin we are having, whether my structure or plant is able to qualify or not. I don't know whether I am able to answer you, sir.
I wanted a specific example where plant had to be shut down for this type of...
No. So far we have not gone for this stage, sir. No. Not to best of my knowledge, sir. Now coming to your first question, sir. 2004 tsunami was definitely not considered, in my opinion, while designing the MEPP, because this is whatever, sir, actually after this, in 2005 we had one IAE workshop over there. So from that knowledge, actually we have tried to get the information on that basis. Sir, you can correct me if I am wrong. So it was not considered particularly from the tsunami consideration for the plant grade level design of the MEPP. But yes, after we have evaluated the effect of the 2004 tsunami, MAPS and Bhavani in particular there where the additional mitigation structures were constructed, so that in near future, whatever the design margins as stipulations are there, 6.5 meters, 4 meter above the grade level, this flooding is not going to be there in future events. Similarly, sir, when we were doing the exercise for the our Bhavini, we have also made a small approach as to what happens to Tarapur. Tarapur also very coastal side, So there also, because we are having their natural protections, we are having this training bund, and big bunds are there. Basically, they are also acting as a energy dissipation devices. Although we have not done the detailed calculation as to what will be the effect of this tsunami of what magnitude, because if you say historical tsunami, the maximum tsunami actually came from the Arabian Sea. That is that Macron fault, But that we have not considered. Internationally, sir, nobody considered. That type of approach that was a few decades back, but it is historical only. So there is no, recorded data for a particular tsunami which is really influencing. On that basis, probably the code has taken the two different grade level approach. One for the east coast, another for the west coast. That was the reason, sir.
Sir, I can add one point. So I will add to this. You can tell that. I think you were coming to that. You can so now you are a different hat, so I will. Well, the tsunami was not in particular covered for maps, but tsunami.
Thank you. If no more questions are there, let us clap for our Arvind Srivatava ji for wonderful presentation.
Thank you very much.